All right, 51, we're supposed to do the midpoint n times for f of x equals x. So first of all, let's just get kind of clear. If we're doing r n times or l n times or m n times, how does that going to look? So if I'm going to do r, and I'm dividing an interval up a bunch of times, and a is where I start at, and the width is some change in x, then I'm going to be on the right side of each of these. I'm going to be going f of a plus 1 width to be on the right side, and then plus 2 widths. So plus the width times I, as I goes from 1 to n. If I want to be on the left side, then I want to stay on this side. So one way to make it land on this side after one change in width is to first back up 1 width and then jump 1, then 2, and 3, and 4, and 5. So you can do f of a where I want to be, back up 1 width, and then go plus delta the width times I, delta x times I. So go to the start, back up 1 width, and then when I is 1, you'll go forward on 1 width, and then when I is 2, you go 2, and then 3, and then 4, and then 5. Now, if I want to do midpoints, similar idea as the last one. I'm going to go to A, but if I want to land on the midpoints, I want to back up a half of a width and then jump widths to land at the midpoints. So I'm going to back up a half of a width, then go delta xi, delta xi. So if I want to do midpoint here, for this function, from 0 to 2, I'm going to have the limit as n goes to infinity of the width of the interval is going to be 2 minus 0, which is 2 over n. And I can pull that out of the sum, and then I'm going to go from I equal 1 to n of f of, I'm starting at 0, back up a half of a width because I'm doing midpoint. So half of 2 over n is 1 over n. So I'm backing up a half of a width, and then I'm going to jump the width, plus 2 over n times I. Okay. So this 0 is not going to do anything. So I'm going to have to plug this into f, which is just x, and so y is equal to the x, and so it's just going to be the limit as n goes to infinity of 2 over n times the sum as I goes from 1 to n of minus 1 over n plus 2 over n I. This is a sum, so I can split these up, and so I'm going to have the limit as n goes to infinity of 2 over n times the sum as I goes from 1 to n of 1 over minus n plus the sum as I goes from 1 to n, 2 over n I. Now the minus 1 over n can come out, or the 1 over n can come out, so This could be the limit as n goes to infinity of, this would be times this, so I take out the negative n, or let's just do this. 1 over n is a constant, and we got to do it n times. So this would be minus 1 over n times n, which is minus 1. And then this 2 over n comes out. And then I'd have the sum from I going 1 to n of I, which is n squared over 2 plus n over 2 from the formula in the book for I going from 1 to n of I. So this times, okay, let's just lay them all out here. Uh, 2 over n times that is minus 2 over n. And 2 over n times this is two over n is what I pulled out of here. And this is another 2n. So that's 4 over n squared. I'm just checking myself here. 4 over n squared times n squared over 2 plus n over 2. Okay. This times this, I'd get the n squareds would cancel, and I would get just 4 over 2, or 2. And 4 over n squared times n over 2 is just 2 over n. And these would cancel, but they also go to 0 when n goes to infinity, and I get 2 for my answer.